So we're doing lesson 6.1, number 14 of James Stewart's Transcendental Calculus Book 6 edition. In this problem, we're going to be finding the volume of a cylinder, and then they already gave us the functions which will enclose the area, and that will be y equals 1 over x, y equals 0, x equals 1, and x equals 3. And you rotate the section that it will enclose over the line of intersection, which in this case is y equals -1. So the first thing you do is you graph the problem, and I've done so already, and then that's y equals 1 over x is this graph right here. The function x equals 1 is there, x equals 3, and then y equals 0. And as you can see, it encloses this section right here. In this problem, the limits or the range will be will be 1 to 3, because as you can see, that's where the start of the function is, and then that's where x equals 3 is where, not the function, the area. 1 is where the area begins, and then 3 is where the area ends, and so you want to take that the volume of those numbers. So first you find the radius, because as you can see, from the area that is enclosed to the line of rotation, there's a part that's missing, and so it's essentially going to be this washer effect once this area is rotated, or this section is rotated. And to make a washer, you need the big radius minus that small radius, which is, as you can see, right there. So to get that, we get the big radius, which in this case is 1 over x to -1, because it's the top function minus the lowest function, which in this case is the line of rotation. So it's going to be 1 over x minus -1, because obviously to find the number is going to be the top minus the bottom, and we do so again for the small radius, which in this case is 0 minus -1. So once simplified, as you can, that's going to be 1 over x, since the ones cancel each other out, and I've done so. So the radius is right here. Then you set up the problem, and as you can see, the integral is going to be from 1 to 3, and then the formula is pi times the radius square times the height. So I plugged in my radius, which is 1 over x, and that became 1 over x squared. Then I plugged in my height, which is right here, and that's my height, and then it's dx, because as you can see, we're essentially just taking the volume of one bar or one line or block, and we're essentially integrating it to find the volume of this whole area. So going back to the problem, you're going to rewrite 1 over x squared as x equals -2, so you could integrate it easier, and that essentially will become negative. So this problem will become pi times -x to the -1 power, and of course you integrate that from 1 to 3. And so then you distribute the pi, so it's going to be -pi over x, and then finally you use the numbers, and then that's going to be -pi over 3 minus -pi, and then that essentially when you rewrite it, it's going to be pi minus -3, and that's your answer.